Right, so this is the challenge question. There are two cars heading towards one another on a track. They're separated by 5 meters on the track. Car 1 switches on, accelerates at 1 meter per second squared. That should be squared, folks, not -1. Towards car 2. A second later, car 2 starts to switch on and accelerates at 2 meters per second squared towards car 1. So when and where do they collide? Well, let's start off by drawing a diagram of the situation. So we've got car 1 starting here at x, we'll call it x01 equals 0. And then we've got car number 2 over here at x02 equals 5 meters. So there's a displacement of 5 meters there. So we can set up arbitrarily our axis to look like that, and let's say this way is positive. Remember, we just try to define which way is positive and which way is negative. So write down some of our initial conditions. So the initial position, so initial conditions. Our initial position, 1 naught, is 0 meters. Our initial position for our second car is 5 meters. The acceleration of car 1 is 1 meter per second squared. The acceleration of car 2 is minus 2 meters per second squared as it's heading in the opposite direction. We have this distance between them, L, which is 5 meters, and we have a time delay, capital T, which is 1 second. So this is going to complicate things a little bit, this delay and also the difference in space, but we will see that we can sort this out. So they meet when their position is the same. So after some time x1, so some other position x1 after some time t, x1 equals x2, so their position is the same. So let's have a look at everything we have. We've got acceleration, we've got times, we've got, so actually we're looking for t, and we're looking for this position x. Okay, so first of all we'll solve for the time. Look, we've got time, position, acceleration, then there's one equation of motion that we're very familiar with by now, xf minus x naught is equal to v naught t plus at squared on 2. So we look at the equations of motion. So after some time, after t, we can look at the two cases for the cars. So for number 1, we use that equation. Our v naught is going to be x naught is going to be 0. V naught is going to be 0. So we have x1 is equal to a1 t squared over 2. That's equation 1. For car number 2, however, we have to include a delay. So there is some initial velocity after a given time. So we have x2 is equal to capital L. So this distance. Remember, this is an initial distance that the other car has travelled, plus a. We also have to include the time delay here in our time part of the equation. So that's a difficult part of the this problem solved. We have to include this character here, which is our distance between them, and then we also have to include this guy here, which is the time delay. So like I said, they collide when 1 equals 2. So we can set up that equation now. We can say a1 t squared over 2 equals L plus a2 t minus t squared. Make sure we get those squared terms right this time. Divide by 2. So what we want to do is try and solve for little t here. So we're going to have to do some algebra, and it gets ugly. Let's just say that. So if we multiply both sides by 2, so multiply by 2 both sides, we get a1 t squared equals L plus, 2L plus a2 t minus capital T squared. So now we probably want to expand out that bracket, expand out this bracket. So we're going to get a1 t squared equals 2L plus a t minus t, t minus t. So that's a difference of two squares, which gives us, I'll just make that an equal sign, sorry, which equals 2L plus A, that should be A2 guys, A2, outside of t squared minus 2tt plus t squared. So that's just the difference of two squares that we have there. I would probably expand this out again. So we're trying to get our t by itself and to get into a formula that we can solve the quadratic formula. So we're going to get a1 t squared equals 2l plus, just to redo that, plus a2 t squared minus a2 2 capital T t plus a2 t squared. Right, now we're starting to get into a form that's maneuverable into a quadratic formula type of arrangement. So therefore a1 t squared minus a2 t squared, just taken that guy and put it on the other side, equals 2l minus 2a2 tt plus a2 t squared. So just a little bit more working than the previous solution that we had up here, just so you can follow through. We can group the a terms there, so we get a1 minus a2 t squared. Let's get our bits and pieces over onto the left-hand side of the equation so it looks like a quadratic. So we can subtract, we can add 2a2 tt from both sides, so we get add 2a2 t that side of t. Yes, that's correct. And then we take if we group all the other terms together, we get minus 2l plus a2 t squared equals 0. So that's in the form of the quadratic formula, which I'll remind you about. It's if we have something that's in the form of a, say it's ax squared plus bx plus c equals to 0, we can solving for x there, we can say x is equal to negative b plus or minus square root of 4, b squared minus 4ac all over 2a. So that's what we have. This is a, this is b, and this is c. And we can throw that into our quadratic formula. So that's going to end up with something ugly looking, which solves for t as 1 over 2 times a, which is a1 minus a2, outside of negative b, which is negative 2a2t, plus or minus square root of 2a2t, which is b, squared, minus 4a, a2, times negative 2l plus a2 t squared. Ugly. We can put our values in for that. We know a1, we know a2, we know capital T. We can just put those values. We know L. We can put that all in. We sub it back in, and we get two answers. I won't bore you with that. You can just put those values in for yourself. You'll get 2.43 seconds. You'll also get an answer that's minus 1.097 because it's a quadratic, but we can't use that one obviously because it's negative time. So now we can just put this back into equation 1. So back into 1. And equation 1 was x1 equals a1 t squared on 2. So we can put our values in for that. We get 1 times 2.43 divided by 2 is 2.95 meters. So that's our two answers.